वेलकम बैक टू यूट्यूब चैनल द बिटकोड। तो लास्ट की वीडियो में हमने टाइम कॉम्प्लेक्सिटी एंड स्पेस कॉम्प्लेक्सिटी से रिलेटेड कुछ सिंपल एग्जांपल्स को कवर किया था और साथ में हमने ये भी सीखा था कि टाइम कॉम्प्लेक्सिटी ऑफ एनी प्रोग्राम इज नथिंग बट फाइंडिंग द लूप्स ओनली। तो आज की इस वीडियो में हम टाइम कॉम्प्लेक्सिटी एंड स्पेस कॉम्प्लेक्सिटी से रिलेटेड कुछ और लूप रिलेटेड एग्जांपल्स को कवर करेंगे। So let's get started. So in this question, we have to find out the time complexity of this program. तो जैसा कि हमने previous वीडियो में सीखा था कि time complexity of any program is nothing but finding the loops only. So here in this program, first we have to find out how many statements do we have. So this is our first statement. This is our second statement, and this is our third statement. So time complexity of this program will be the sum of time complexity of statement 1, statement 2 and statement 3. But statement 2 और statement 3 यहाँ पे loop के अंदर execute हो रही हैं. Time complexity of statement 1 is big of 1. So the time complexity of statement 2 is nothing but the number of executions of statement 2. So जैसा कि हमने previous example में देखा था, the time complexity of this statement will be big of n, because statement 2 जो है वो n times execute हो रही है इस loop के अंदर. Now we have to find out the time complexity of statement 3. तो हमें चेक करना पड़ेगा कि ये statement कितनी बार execute हो रही है. So when I is equal to 1, j is going from 1 to up to n. When I की वैल्यू अगले loop में जब 2 होती है तब j की वैल्यू is going again from 1 to n. When I is equal to 3, then j is again running from 1 to 3, 4 up to n. So like this, the value of I will go until n, and similarly the j will run for 1, 2 up to n. So here we can see that for each value of I, j is running n times. For each value of I, j is running n times. So its total time complexity will be n into n. The time complexity of statement 3 will be big of n square. And the total time complexity of this program will be nothing but sum of the time complexities of statement 1, statement 2 and statement 3. That is time complexity of statement 1 plus time complexity of statement 2 plus time complexity of statement 3. So the overall time complexity will be big O of n square. So one thing we can learn from here is जब भी loop एक के बाद एक आता है, one after another loop, the time complexity will be added. But जब कभी भी दो loop एक साथ आते हैं, both loop at once, उस केस में हम क्या करते हैं, time complexity will be multiplied, जैसा कि हमने यहाँ पे देखा था. तो एक के बाद एक लूप आता है तो हम हमेशा ऐड करेंगे, और दो लूप एक साथ आते हैं तो हम हमेशा मल्टीप्लाई करेंगे. So let's go to the next example. So based upon the learnings so far, we have to find out the time complexity of this program. So in this program we have first statement printing hi. This is our second statement, and this is our third statement. So here we can see that this loop and this loop are coming one after another. So यहाँ पे हम इन दोनों की टाइम कॉम्प्लेक्सिटीज को क्या करेंगे, ऐड करेंगे. सिमिलरली यहाँ पे हम क्या देख रहे हैं कि दो लूप एक साथ आ रहे हैं, तो यहाँ पे हम टाइम कॉम्प्लेक्सिटीज को क्या करेंगे, मल्टीप्लाई करेंगे. So let's apply these rules. Time complexity of statement 1 is nothing but big O of 1. Time complexity of statement 2 is nothing but big O of n. Time complexity of this statement 3 will be the total number of executions of statement 3. the total number of executions of statement 3 will be n into n by 2. जैसा कि हमने previous example में देखा था कि हम यहाँ पे multiply करेंगे. The value of I is going from 1 to n and the value of j is going from 1 to n by 2. The total number of executions of this statement will be the multiplication of the values of I going from 1 to n and the value of j going from 1 to n by 2. That is n into n by 2. The time complexity of this statement will be n square by 2. And the overall time complexity of this program will be big O of 1 plus n square by 2, which is nothing but big O of n square. So the constants are always neglected. Let's go to our next example. So in this example, we see that there are 4 programs and we are given the time complexities of each program. Time complexity of program P1 is 100 n square. Time complexity of program P2 is 10 n square. And the time complexity of P3 is 2 n square. Time complexity of P4 is n square. So the time complexity of all these programs will be big O of n square. All the constants which are appearing in the time complexities will be neglected. So while calculating the time complexities and the space complexities, we have to neglect the constants. So with this learning, let's go to next example. So this is based upon the previous learning that we have to neglect the constants. So we have to find out the time complexity of this program. Time complexity of this program will be the total number of executions of this statement 1, which is big O of n, and the total number of executions of statement 2, which is big O of 10n, because this statement is running 10n times. The total time complexity of this program will be big O of 1 plus 10n, which is nothing but big O of 10n, and ultimately the final time complexity will be big O of all these constants will be neglected. So let's go to the next example. So in this example again we have to find out the time complexity of this program. This is also based upon our previous learning. The time complexity of this statement is big O of n. This is running one time only, and this statement, if you see the loop conditions, this is running 100 times. So the time complexity will be big O of 100. The total time complexity will be big O of 100 plus 1, that is big O of 101. This is a constant. So the ultimate time complexity will be big O of 1. So here 1 does not mean actual 1. Here 1 actually representing constant. So this program is going to take constant amount of time. Let's go to next example. So let's suppose we are given 2 types of loop in 2 programs. This is present in program P1. This is present in program P2. The time complexity of the statement which is running inside this loop will be big O of n, and the time complexity of this program will be big O of n minus 1, because the statements inside this loop are running n minus 1 times. The final time complexity of this program is big O of n, and for this as well the big O of n, because here this is a constant value which will be neglected. So the time complexities of program P1 and the time complexity of program P2 are same. So similarly related to this, we take another example. So we are given 3 programs, program P1, program P2 and program P3. We have to find out the time complexities of all these programs. Because this statement is running only once, which is a constant, we neglect it. This statement is running n times, so the time complexity is big O of n. The total time complexity of this program will be big O of n. For program P2, we neglect this because this is running only once. And for this statement, this is running n minus 1 times, because here we have I is less than 1. But in program P1, we have I is less than or equals to 1. So the total time complexity of this program will be big O of n minus 1. Finally, big O of n, because the constant values will be ignored. Similarly, if we go to the program 3, the time complexity of this statement will be ignored. We neglect this because this is running only once. And if we go inside the loop, the first statement is running n times, second statement is also running n times. So the total time complexity of this part will be we go of 2n, and ultimately the time complexity of this program will be we go of n. So the time complexity of program P1, program P2 and program P3 are same, we go of n. The difference is only in the condition. Here the condition is I less than equals to n. Here the condition is I less than n. Here we have two statements inside the loop, but the condition is I less than or equals to n. So it doesn't make a difference if the program is running with I less than n, if program is running with I less than equals to n. And also it doesn't make the difference how many statements are present inside the loop. To explain it more, let's take another example. So in example number 11, we have a program P which is taking 24 hours of time to finish its execution, and it is having 100 loops inside it. But when I'm running the same program without any loop, it is only taking constant time, that is 1 second. But here CPU is taking 24 hours. We can say whenever CPU spends more time, that part of the program is most valuable part. Most valuable part means, from this example we can see that what is the most valuable part. Most valuable part is nothing but loop only. So with all these examples, we have learned that time complexity of any program is nothing but finding loops only. Loops are the only part which consume more time and are the most valuable part of a program. Example number 12, we see that there is a loop, and inside that loop we have 1 lakh of statements, and this loop is running n times. The time complexity of this program is nothing but big O of lakh of n. This is nothing but big O of n. So what we have learned from this example is how many statements are written inside a loop that does not matter. तो ये हमने पिछले एग्जाम्पल में भी देखा था कि यहाँ पे प्रोग्राम P3 में 2 स्टेटमेंट लिखी हुई थी, बट प्रोग्राम P1 एंड P2 में सिर्फ एक ही स्टेटमेंट रखी हुई थी. But the time complexity of all these programs P1, P2 and P3 is big O of n. So that's it for this video. So next video में हम टाइम कॉम्प्लेक्सिटी एंड स्पेस कॉम्प्लेक्सिटी से रिलेटेड कुछ और एग्जांपल्स को कवर करेंगे, लाइक डिपेंडेंट फॉर लूप्स एंड इंडिपेंडेंट फॉर लूप्स. अगर आपको किसी भी पार्ट के रिगार्डिंग कोई भी कंफ्यूजन है तो आप कमेंट सेक्शन में लिख सकते हैं. सो स्टे ट्यून्ड, सी यू इन द नेक्स्ट वीडियो, बाय बाय.